Newton's Third Law of Motion by Abby Steffen
and Faith Williamson.
Newton's Third Law. The definition: whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object.
The demonstration.
Good.
As a basketball is rolled and hits another smaller ball with a great deal of force, the smaller ball exerts a force back as well.
Another demonstration. As a smaller ball is rolled and hits the basketball does not go as far because the force of the smaller ball does not have enough momentum to push the bigger ball.
The explanation. As a ball is rolled and hits another smaller ball with a lot of force, the smaller ball exerts a force back as well. The bigger ball has a lot of mass and velocity compared to the smaller ball, so it has more momentum. The more mass and velocity that the object has, the more momentum it has. The first ball exerts a force on the smaller ball, which is the action force. The smaller ball exerts an equal and opposite force, which is the reaction force.
Action and reaction forces can cancel each other out and create a net force of 0. But they do not always cancel each other out. For example, the action and reaction forces may not react on the same object, as in a turtle swimming. The action force is created by the turtle moving its legs in the water, and the reaction force is what moves the turtle as it swims through the water.
Momentum is a product of an object's mass and velocity. The momentum of a still object is 0. For example, the balls at first had a momentum of 0, but they picked up momentum with the force that they were given. In football, teams are in their positions and holding still until they say, "hut," and everyone goes into motion. The defense attempts to tackle the offense at their legs as they start to run, and the loss of momentum in one person is a gain of momentum in another person. The loss of momentum in one object is a gain of momentum in another object. So remember, momentum equals mass times velocity.
All these things build up into Newton's third law, which can be found in everything, from chairs and bikes to swimming and jumping, just to name a few. Newton's third law is important, and it needs to be understood to be able to understand how objects in life work.
La Fienne,
aka the end.
we hope you enjoyed our presentation.